Um, Here we go. Today we'll be talking about working with suppliers and manufacturers, how to define them, find them, vet them, negotiate, and manage. Lots of different topics there. As usual, my name is Matt Verlinich. I manage InnovationWorks manufacturing programs. Also part of the hardware team, we have Jesse Mazzoni, who manages the Alpha Lab Gear Accelerator program, and Mike Formica oversees all of our hardware initiatives at InnovationWorks. We are proud partners of the Next Core Manufacturing Accelerator program, who is sponsoring this. Next Core receives its funding for this program from the NIST MEP network, which was a network of economic development organizations or nonprofits who support manufacturers in the U.S., all across the U.S. Our local partner is Catalyst Connection, which has a similar footprint of counties that they serve to InnovationWorks here in southwestern Pennsylvania. The program is also sponsored by NISTAR, which is the New York State Department of Science, Technology, and Innovation, similar to the Ben Franklin in Pennsylvania. And all of this curriculum was put together in collaboration between the Rochester Institute of Technology, aka RIT, Fuse Hub, which is a New York MEP program, Catalyst Connection, which is our local MEP or Manufacturing Extension Partnership, and then InnovationWorks, which is Southwestern Pennsylvania, Ben Franklin, the company that I work for, in case you didn't know that, and the company that manages Alpha Lab Gear. So, 8-week curriculum that we've sort of laid out here started with product development and specifications. Then we talked about bill of materials and bill of process, then cost modeling and risk management, introduction to quality, design for manufacture and assembly, and now today we are going to be talking about working with suppliers and manufacturers. Next week, we'll do a bit of a deeper dive into quality and testing and certifications. And then the final week, we'll talk about everything else that you'll need to consider for scaling up or taking the next step, whatever that might be for various different stages. So, general housekeeping recap before we get started. Remember that everything is on the scalableinnovation.org website under the Manufacturing Bootcamp. There's a link up here. I post all the recordings there afterwards. It also has the curriculum outline and the sign-up form for the email list, which I use to sort of notify and provide updates to everybody about all of this curriculum and any sort of additional funding that we have that comes available, like our scalable grants, or if there's any more Next Core funding that becomes available. I think it's also useful to do a little recap of the homework assignments, because I mean, I don't follow up. I'm not like a teacher grading your homework assignments. So just as a reminder that these are the important sort of documents that we think are critical to really managing your manufacturing process. From session 1, it was your product requirements document, which documents all the general specifications and customer requirements of your product as a whole. Session 2 was the bill of materials and bill of process, which documents all of the components of your product and ideally the associated specifications with those components. And then the assembly process for it, which is your bill of process or BOP. Session 3 was cost and risk management, which sort of entailed a cash flow forecast, so you can understand what your volumes are and how much money you have to budget for tooling or non-recurring engineering expenses versus actual sort of prototyping, development, and inventory, as well as an initial risk tracking document to identify sort of all of the known unknowns that you are tackling or want to tackle, as well as sort of fleshing out a more costed BOM and BOP. And that's an important sort of consideration here, is that all of these documents are constantly evolving. And so setting them up in such a way that allows you to version control them and continue to iterate on them is really important for keeping all of your information organized as you continue to scale and take the next steps in your product development life cycle. Session 4 was an intro to quality, which is very much an overview process. And so the homework from that was prototype quality test plan. So how will you know if you're actually producing your product effectively and that it's meeting your customer requirements, and what do those sort of SOPs look like? That's that document. And then last week or 2 weeks ago, before Thanksgiving, or we talked about design for manufacture, design for assembly, and then design for X as a variable, whatever might be critical to either your customers or your ethics of your company, like sustainability, sustainability, logistics, environmental considerations, etc. Last week, we talked about the design for manufacture, design for assembly, or last session, I should say. Did anybody sort of identify one and start to examine their product in favor of that? You can just shout it out. If not, I'll move on in a couple seconds here just to keep things moving.
We've been looking at design for assembly, making these components easier to assemble, making sure that we would do our the soldering at one station and the assembly at another station to change the different cost levels. One's a skilled labor, one's an unskilled. So we changed this piece around to make sure that it would fit.
That's awesome.
Yeah.
And so are you going to be assembling those in-house, and for how long?
No. They are, our contract manufacturer is Penetronics in Washington, Pennsylvania. And so they're going to be doing all of that. We are doing less than 100 runs of them, but until we turn it over to them for several thousand.
Gotcha. That makes sense. So you're actually helping them optimize their assembly process through your own in-house testing.
That's right. So if Pierce is doing it and he sees that it is hard to do, then he's just going to make it a lot easier for himself and therefore easier. So I told him his next run's 1,000, so it's going to get real good.
That's awesome.
Yep. We're also in the thick of it. On the electronic side, we've gone through the design for manufacturing. Actually, with our manufacturer, they've been awesome in terms of giving us little guidance that will set us up for doing like EMI and vibe testing later. So that they produce a lot of products. So they had to have a great selection, guidance on little tweaks to make in the board that were inconsequential to us, but set us up for good testing later. And then on the plastic side, we're actually redesigning a few parts too, mainly to handle is a lot of the stuff I watched your video because I had technical difficulty last time, but a lot of the stuff you were talking about, the waste. So we got great guidance from somebody that does a ton of injection molding on parts. So they took a look at all of our parts and gave us ways to basically separate out everything so that we can take advantage of the waste, put the plastic back in the injection molder, and then kind of recapture all of that. So we're in that process now.
Oh, that's awesome. Thank you for sharing, Mike and Stephanie. And you're using EPD for the electronics?
Yep.
And who is the plastics person?
We're still talking to manufacturers on that. A lot of them because we're doing a soft touch over molding on our products, and a lot of manufacturers have machines that are too high temperature, too high pressure to do what we want to do. So that's another part of our design modification, is to make those parts a little easier for people to work with. So we're still investigating vendors on that side.
Gotcha. Cool. Thank you. So speaking of feedback, I just wanted to remind everybody that I would really appreciate it if you could provide any feedback or thoughts on any of the curriculum that we've done so far. If you really liked or found anything valuable, or if you wish there was more detail on anything, there is a column in the curriculum overview, which is linked right here, and also it's linked on the Scalable website. There's the feedback column, and then there's also a did you watch recording. So for like Stephanie, you had technical difficulty last week, but you watched after the fact. If you click on the link, which is actually now live after I made that screenshot, you can just indicate if you weren't able to make it, but you watched it instead. That'd be great. Very helpful for us. So I also wanted to overview a few things that I have gone through in open office hours with different people for different types of stuff. just to sort of make you think about if there's anything that maybe I can help you with, just with reviewing documents, reviewing the homework, sharing additional resources that we didn't get time to delve into in any of these presentations, finding suppliers, reviewing technical documents, helping to identify those unknown unknowns like we talked about back in the risk management side, where just getting some outside perspective to see if there's anything that you're not considering that you didn't even worry about. Can help find something to keep you up at night, among other things. So just a little list there. Today, we'll start out by talking about an overview of what type of suppliers are out there and how to identify them, then what type of documents you'll need in order to select a supplier, things to consider for a factory tour, and how to sort of weigh one supplier against another. Then on the other side, no matter how good your supplier is, there will always be some element of in-house project management that you need to maintain, as well as the relationship management, negotiations, getting things under contract, protecting your IP, all of those considerations. You can sort of think about this presentation as a huge checklist of things to consider. Maybe a lot of it is just doesn't apply, but it's at least a good perspective to have the opportunity to think about it. Homework from today is to identify your current suppliers and see if there's any potential ones that you might want to begin exploring to find a redundant supplier, and then also identifying potential new suppliers and what you would need to do before engaging them in order to effectively have a productive conversation. So, intro to types of suppliers and relationships. First, here's just a list of things that you can potentially outsource, and it's basically everything. You can find somebody to do pretty much anything you would need, but what it comes down to is a source of a question, should you outsource any given thing? So everything, including contract manufacturing, materials and parts, subsystem assembly, tooling, fixtures. You can outsource even capital equipment. You can get some contract manufacturers and negotiate with them to buy a piece of equipment that you don't even own. So you can effectively outsource capital equipment. You can outsource distribution to 3PL services. There are more and more of them, specializing in all sorts of different sizes and volumes. A lot of contract manufacturers also provide that as a value-added service. And then you can also outsource any sort of design or technical services that you might need in order to engage those. Each one of those is going to require identifying a different kind of supplier and then sort of knowing the vernacular of what you're looking for. So some critical questions to ask yourself in getting started on that is, how will you know what to make versus what to buy? Are you going to assemble this product yourself or hire a contract manufacturer? Ask yourself what kind of relationship you want to have with the supplier. Know how are you going to select and contract, basically bring into an agreement. And that could be a formal legal document, or it could just be an internal document for you to understand how you intend to communicate and what you expect from the supplier, what they expect from you. How will you manage all of this information in terms of software and also style of relationship management? And then will you have redundant suppliers for any given parts, and how will you identify what those parts are that you want to have redundant suppliers for? Some things to consider in the question number 1, make versus buy. Remember from our discussion in 3, identifying what is the relative cost of any different component and how critical is that to your overall product performance and cost. So sorting your bill of materials based on the percentage of the total BOM cost is one effective way of sort of at least identifying how important it is economically, maybe not necessarily functionally. Also really critical, which I find a lot of startups don't ask themselves this question very critically, is what are your actual internal capabilities? It might seem like a huge price tag. Like, what are you really good at? It might seem like a huge price tag to get a quote from a professional service company to say this is going to be $100 an hour. But if it takes them 1 hour to do it and it takes you 2 weeks to do it, how much do you have to be able to charge? How much are you actually paying yourself to offset that cost? Is it really worth you learning it and doing it and potentially making mistakes? And that requires some introspection and honest self-awareness. What is your availability of different resources? Do you have time? Do you have access to expertise? Do you have capital that you can spend on solving different problems? Consider fractional resources. There are increasingly more and more fractional CFOs, COOs, people with real experience in any given industry who you can sort of rent time from or pool with, even maybe companies in this cohort if you all have similar needs and can contract, basically get some economies of scale on buying somebody's time. Capital is an important one. Required speed and volume is another one that requires some very honest introspection. If you ask suppliers for quotes and for 1,000, 5,000, and 10,000 products, that might really throw them off and cause them to quote you on a large and expensive tool in order to meet that production volume, and then you can walk off with a false assumption of how much it actually costs when you inevitably sell 100 for your first year and then 500 in your second year and 1,200 in the third year. You never needed that quote for 5,000. Intellectual property, huge factor. What is your actual key differentiator, your performance, your critical selling proposition, and how can you protect that? We'll talk more about that later. And also strategic value. There's definitely significant value in talking to maybe your distribution partners or your customers and figuring out if there is potential portions of your services that you can outsource to them. So in comparing owning your own manufacturing versus engaging a CM, some things to consider. There's a lot of benefits in working with a contract manufacturer. They oftentimes have experience. They have economies of scale on overhead. So your overhead for doing a product or a task that you're not accustomed to is going to be higher than their overhead for doing something that they do all the time. They have access to networks of suppliers for both tooling and parts, which can provide them with more significant purchasing power. I will say the counterpoint to that is also don't assume that they will. You actually have to engage them. There's some electronics contract manufacturers specialize in things like power supplies, and so they will have specialized equipment for higher power electronics. They'll have a lot more economies of scale on ordering higher powered components versus miniature components. And so you go to somebody who's the majority of the products they make are very small, and then you ask them to make a very big high powered device, they might not be as effective a fit as a different contract manufacturer. So that also requires you to do some homework to understand who you're actually talking to in order to get all of these benefits. Regardless of, once you find that fit, there's going to be some downsides to contracting your manufacturing out of house. And that is going to be an inherent loss of flexibility, because it's one more link in the communication chain, one more potential for miscommunications, delay in the telephone game of communication. There's intellectual property risks to that as well, but there's also sort of some intellectual property benefits depending on the type of supplier relationship, which we'll talk about later. It can make it more difficult to determine the source of quality issues. Again, the counterpoint to that is oftentimes manufacturers have more efficient quality programs set up, like especially in the case of ISO 9001 or 9100 or 13485 for medical devices. It can save you a lot of work because they do it all the time for multiple different products, but you'll have to pay for that. And then you also have to understand how to ask the right questions to identify what an issue is when it comes up. It can be difficult to negotiate prices down once you get a price quoted on something. Again, this is sort of a cautionary tale of asking for a very large quote right out of the gate, because you're inherently setting the expectations with that manufacturer that you're going to be a big account for them. And then when you inevitably order virtually nothing, they're going to inflate their price accordingly. But that can be managed just based on how you approach them and how you communicate with them from the start. There's many, many more considerations on that, potential downsides, geopolitical forces, ethics, values, and workplace environment, for instance, sweatshops, and potential even social liability of how you're perceived in the marketplace. Now, nowadays, most people's first go-to when finding a supplier is to just go to Google and search for it. But depending on what you search for, different things will come up, and it might not be immediately obvious what type of business you're actually engaging with. Somebody can be a manufacturer rep or an engineering or other professional service group posing as a manufacturer, but they don't actually own any of the means of production themselves. They just have relationships with people who own the means of production. And if you don't understand that that is what you're getting involved with, you might not be aware that you're actually signing up for not just one addition to your telephone game, but two, because you'll have to communicate with them, and then they'll have to communicate with the actual manufacturer, adding more potential opportunities for failure, miscommunication, quality issues, things like that. It can work out for the best doing it that way, depending on what you're trying to accomplish and where. But it's important to know what you're actually signing up for. So manufacturer reps, just for those of you who are not familiar, they are essentially an outsourced sales force. So a lot of manufacturers, especially in the US, do not maintain a sales force in-house on their payroll. They instead strike up deals, basically commission-based sales deals with people who will represent them. And so these manufacturer reps oftentimes have more extensive relationships with a lot of different manufacturers, and therefore can provide some real value to you in understanding where your product fits in this particular manufacturing method and who is the actual right supplier, because it's in their best interest. But sometimes they might charge you for services where they would then function more like a professional service or a consulting firm. But more oftentimes, the traditional manufacturer rep makes a commission based off of the work that they ultimately get you placed into. For instance, Penetronics does not have an in-house sales force, or maybe they have some small one, but they also rely on a company called TMC, or at least the last time I engaged with them. TMC will then basically get the deal set up and then make a percentage off of that, which Penetronics pays them after you pay Penetronics. If that's sort of how the work ultimately came to them. But depending on the negotiation and the relationship that they have with that company, they might have exclusivity where any business that comes in, or it might just be if business comes directly to Penetronics, then there's no commission on that. It's all very gray area. There's your traditional contract manufacturers, like the most visible one of those is Protolabs. You can go to Protolabs, get a quote from Protolabs, you pay Protolabs, and they send you a part from Protolabs. And it's made in-house in Protolabs facilities by Protolabs employees on Protolabs equipment. It's completely vertically integrated, and they only do specific things. There's many hybrid models to that too, where there are electronics manufacturers who will do box builds and they'll do conformal coating, but they'll outsource PCB boards, or maybe they outsource coating, but they do the placement of the components and the ordering of the components in-house. Sheet metal manufacturers oftentimes will provide powder coating or anodizing or other finishing services, but they don't do any of it in-house, and they're actually relying on a subcontractor. And it's important to make sure you understand and ask all of those questions. There's other hybrid models out there, like marketplace models, where like MFG.com is a marketplace model where they are just a website that builds relationships with manufacturers, and then they build relationships with startups who have parts. And the startups go onto their website and place a open project call, basically, like saying, hey, who can make this part? And then it's all of the manufacturers that this marketplace has relationships with will get a push notification to say, hey, do you want to quote this job? So it can be an effective way of getting a large number of quotes on any given product, but it's then outsourcing all of the work of vetting those quotes to you, as well as outsourcing all of that initial definition of the project scope to you. Alibaba is a hybrid of all of those systems, where there are CMs on there are OEM manufacturers on there are trade agents on there, and then there are hustlers on there who will do whatever. But a bit more on that later. In addition to those, I wanted to throw out there that there are freelancers and makers out there, like small independent contractors, who can oftentimes be very useful for keeping your costs lower and providing a lot of value-added services, but they might not necessarily have the same bandwidth as a professional consulting or professional services company. And those can be found through economic development organizations like IW, maker spaces like Protohaven, or certain websites like Makers Row they focus specifically on that. Also Upwork and Fiverr can do things like help you find individuals like that. It's just inherently you're going to end up taking more time with that. I also, in searching for suppliers like on a ThomasNet, there's also inevitably what I would have deemed, for my purposes, OEM, original equipment manufacturers on there. They are manufacturing businesses that essentially are in the business of producing their own product. For all intents and purposes, their internal structure is all organized around making their own product. But whenever they have downtime on a particular machine or for particular employees, they will contract out a portion of their services. That can be an effective way of finding something local and cost effective, but again, you're going to sort of sacrifice your potential lead times on that. Something to consider. There's also, which we'll talk a little bit more later, strategic partnerships and investments for different types of suppliers, where they can be sort of OEM manufacturers. One of our portfolio companies makes a product that helps with heat transfer and electronic components. They can work with a major international electronics manufacturer, and utilize some of their supply chain to ultimately manufacture this product and get it directly into the product, because they're not really selling it to end consumers like on Amazon. They're selling it to manufacturers. So it makes sense to have a strategic relationship with an existing manufacturer that makes the adjacent product. So production facility terminology, this is just some useful definitions that you might come across as you go and try to find and vet different suppliers. A job shop oftentimes is a machine shop, and this is a business that makes small batches of a wide range of parts. They call them low volume, high mix businesses. They're great for prototyping and early stage runs. They're very flexible. A dedicated production facility is somebody who's more like an established contract manufacturer. They do specific things and they do them very well, but they tend to specialize in higher volumes and they're not as changeable. And then there's everything in between for flexible production. Here's some more general definitions and things to consider. Fabrication facilities are going to be different than secondary material and finishing facilities. This is sort of an example of what I was talking about earlier, where sheet metal is oftentimes cut and bent in one location, but then there's a dedicated electroplater for doing electronic aided coatings, and there's a separate one for powder coating. So this powder coatings and coaters are just a secondary type facility where they generally don't make or source components. They just apply finishes to them. Electronics are similar. There's an electronics assembly facility, which is like a PCBA you may have seen, printed circuit board assembly house. they put the components on a printed circuit board, but they don't necessarily always make the printed circuit boards. In fact, they rarely do. And then there's also PCB shops, which can be very confusing because PCB shops make just the boards and generally don't place components. You can manage that separately, or you can allow one or the other or a third party to manage both of them. It's all just going to be setting up your supply chain differently. There's dedicated assembly facilities. Oftentimes, this will be more on the packaged goods, like finished, what your consumer will ultimately get, focusing on that side of things. But sometimes there are dedicated assembly facilities for more specific, like a lot of PCBA houses, electronics contract manufacturers will do a lot more electromechanical assemblies than you'd think. Similarly, there's a lot of machine shops that will do a lot more machinery assembling stuff. For instance, if you think about an automated manufacturing line, there are machine shops that specialize in making that type of manufacturing equipment, and so have the in-house resources necessary to put complex mechanisms together, whereas you wouldn't want to necessarily trust an electronics PCBA house to do all of that type of work unless they have prior experience. Pick and pack facility is another word for like a 3PL, logistics fulfillment organization. Amazon. Amazon Fulfillment by Amazon, FBA warehouses are examples of pick and pack facilities. You send them the products, they pick them off the shelves and put them in a shipping box in a million different configurations depending on what other people ordered. There are third-party pick and pack facilities who can do that for you as well. Some good places to start when you're looking to find your supplier, your local manufacturing extension partner. Ours is Catalyst Connection. NextCore is also an MEP for the Rochester, New York area. Economic development organizations like Innovation Works, as well as other regional business incubators, chambers of commerce. These are your sort of third-party opportunities to ask other people for referrals. I would also add to this list asking other startups or asking other people who have made comparable products but not competitive products where they manufacture products. That can be a great place to start searches because you can then get a personal recommendation to get the attention of somebody at maybe a busy contract manufacturer. If you're going to do just a regular internet search, here's a bunch of different websites that are good places to start. ThomasNet, it was the gold standard. It used to be like an Encyclopedia Britannica that they would sell to people, the big green books, like a full row of bookshelves that literally just listed the address and contact information and what they did for every single contract manufacturer in the entire United States. That was all digitized onto a website. It can be a bit of a mess. Because it's all self-populated. This is a place where I was saying, like, you'll find people who are just distributors of components listed as manufacturers when they're not really manufacturers. And you have to sort through all of that. The D2P design to part buyers guide.com is also a great place. They do a free conferences all over the country where manufacturers will come and set up booths and you can just go meet them. It's a great place to meet manufacturers, but they also on their website have a directory of everybody who's ever vended at one of those events. So another great repository of that. They also have a repository for just their sales reps. So all of those manufacturer reps who each individually represent a variety of manufacturers, they have a list of those guys too. Makers Row is the place I was talking about where you can find sort of freelancers or small batch producers. MFG is the marketplace where you can put your job out there and hopefully get bids from multiple people. Alibaba is where you would get stuff from China, and that can be either stuff from OEM manufacturers, like if you just need pumps or an LED or something, or motors, you can find it there, but there are also contract manufacturers who can provide finished goods there that you can just white label stuff. You can say, hey, I want that product, but can you put my logo on it? And now I'm going to sell it on Amazon. And that's partially why Amazon has become just a junk store, because there's dozens of small businesses who order the same part from Alibaba and then mark it up and sell it on Amazon. Fiverr and Upwork are great places for that too. Fictive was another one that I had listed earlier, but not mentioned here. Fictive is one of those sort of service organizations where you would not necessarily know the end supplier, but if you're earlier stage, they can help manage and place your orders for components with the right size supplier, because they have a network of suppliers that they work with, and they provide a layer of professional services on top of that. So here's an example of how a manufacturing extension partner, the whole NIST network that sponsors this, like Nextcore, the types of services they can do. They limit their services to the Finger Lakes region, but they can help you with all manufacturing, engineering, management, marketing, finance, IT, database management, stuff like that. It's basically a subsidized consulting firm, and they specialize in the Finger Lakes region of New York around Rochester, but Catalyst Connection is our partner here in southwestern Pennsylvania, and they do very similar types of services. I can put you in touch with Catalyst if you're interested in talking to them about how they might be able to help you. The next step is, once you've sort of identified those suppliers, before you even approach them, I would recommend thinking about what type of relationship you're looking to establish with that supplier. Is this a strategic partnership? This is what I was talking about earlier with one of our portfolio companies, where the actual competitive advantage of that product is the manufacturing process itself. And it's essential to establish the right relationship in order to capitalize on the IP and the competitive advantage. This is where you would want to find a real strategic partnership. If it is something that is essential but can be done by multiple people, then this is for your sort of custom components. Maybe they're already fully designed, or you're looking to optimize them for manufacture. This is something from your BOM that is going to be like high on there for either the overall performance and your competitive advantage performance of your product, or just from a cost standpoint. Really finding and vetting the right supplier for that. You don't want to do this for every nut and bolt or piece of tape that goes into your product, but you want to identify sort of the most important parts for either cost or performance reasons. Next step down is your semi-transactional ones, and this is for, oftentimes it can be COTS, commercial off-the-shelf parts or systems or sub-assemblies. These are things that you can, maybe there's some element of specialization to it or performance that needs to be verified, but you can add redundant suppliers to this category, but they're not going to be, it's going to take some time, but not nearly the extensive type of relationship that you would have to do with, say, somebody who's designing and laying out and manufacturing your PCB for you for the first time. Then there's the arm's length suppliers. These are people who can be changed in and out, no problem. Amazon, McMaster-Carr. It's just useful to sort of, I find it useful to think about and separate these suppliers in your mind as to how critical they are to the actual business model that you're trying to establish. And that can help you frame, how do you want to actually approach them and manage that relationship? Are you going to be whining and dining them, and taking them out to, making sure that you go visit them quarterly? Or are you going to exchange a couple emails a year and never think about them in between? I will say cash is king, and this is going to be a huge factor in this decision-making process, as well as time. How much time and manpower do you have, or person hours? How strategic is the relationship? Just know that in the United States, things may take longer and require more work to set up those relationships, but they can help you to protect that process and intellectual property more. They also are less cash flow intensive, because you don't have to rely on deposits and upfront payments as much in order to ensure the relationship stays strong. I always advise the early stage companies that we work with to approach your manufacturer, approach your supplier as you would an investor. This person is not looking, especially in the United States, this person is not looking to necessarily make money off of the first transaction with you. They're going to be looking for what is the value of this relationship over time. So presenting yourself as somebody who is a good business opportunity and somebody who has their, for lack of a better word, shit together, so that you're not going to be a burden on them that costs them more money than they ultimately make from you. Those are important. Also, understanding the business model of the person you're talking to is critical. Did they make their money off of high quality, like highly regulated environments? The nuclear industry, medical, food, or are they a consumer product company? Is it big products? Is it small products? Is it thousands of units per year or hundreds of thousands of units per year? Understanding what is their ideal customer and do you fit that? That can save everybody a lot of time. But approaching somebody with just, especially with young engineers, I find that we're increasingly moving to this instant gratification world where it's like you can upload your CAD file and then get your quote back immediately. And there's no relationship, there's no communication, it's purely transactional. Most of the US manufacturing base does not operate that way and doesn't want to operate that way. And if you approach them that way, it's not going to work out as effectively as it possibly could. They're used to sort of whining and dining, getting to know you. Having both of those ready is always a good idea. So have a pitch deck ready to sell them on the opportunity of working with you. Where are you trying to take this business? I've seen so many startups work successfully with manufacturers that they have no business working with, purely because the point of contact which they made initially at the manufacturer loved their product. At the end of the day, contract manufacturers love making stuff. That's why they do what they do. So if they're excited about making a cool thing, you can get a lot of additional value out of that relationship if you approach it that way. But if you just send them a CAD file and say, how much does this cost? You're going to start that relationship in a very different tone. What's up, Mike?
I was so proud when we walked into Penetronics and they had a bat, they had all of the stuff that they've made for us all on display as we walked in. It was so cool to see. And I don't know, it just made my day.
That's awesome. I do love those moments. That's an interesting one too, because I find it very, very helpful when you're looking for or finding suppliers and vetting them to look at what they've made. And some manufacturers will be very public about showing who they've worked with, sharing your brand, what did you make, and also what does that thing do? Because if you see just like this little electronics product, it's like that's just a little black box. Like, why? How do I know that that's relevant to me? But some manufacturers will be willing to actually share, like, we work with Diamond Kinetics, and then you can look up Diamond Kinetics and say, okay, I get what this thing generally does, and my product does a similar thing. So maybe they'd be a good person to work with. Last point on this slide is remember, no one is perfect. There will be trade-offs on both sides. So be patient and remember that you are going to have to project manage stuff. This is a slide from the Build for Scale curriculum, which goes deeper into that, where it's just common misconceptions and mistakes that are made. And I can definitely echo a lot of these. Failure to develop the supply chain strategy before reaching out to the supplier is a big one. Goes hand in hand with are you actually making a reasonable ask of them, or are you demonstrating your ignorance about their business model from the start? Treating suppliers like their servants. This goes with that transactional state of mind. Not understanding how the supplier thinks or their business model. That is a huge one. not understanding your value to that customer. Like, why do they actually want to talk to you or work with you? Is it to make money off of the first sale, or is it to make money off of your first year? Or are they really trying to set up their business for the long haul with you? Do they believe that you can be a significant account, that they're going to invest in whole new production lines just to continue to keep pace with your scale? Or is this somebody who's very frank and says, we specialize in the middle. We'll help you get to where you're going, and then you can work with one of the top 10 CMs in the world if you need to. Not being prepared for the questions that they ask you is a big one. That immediately just shows that you're green. I will say, though, the counterpoint to that is don't front, for lack of a better word. Don't pretend like you know something that you don't, because they'll catch you on that too. It's oftentimes more genuine to just ask them if you don't know what they mean by something. There's a lot of vernacular and a lot of these different specific processes that not everybody's going to expect you to know. Setting realistic expectations is a very important one, and neglecting internal processes is another huge one. And this is, do you have the documentation in place to actually manage changes? This is becoming more and more important in this world, where it's like you can ask for a quote and they'll say, we can get this to you in 50 weeks. And if they say, we can get it to you in 50 weeks for this price, but if we can switch this component, we can get it to you in 6 weeks, is that okay? And then you don't document that. You now are working off of a drawing that is no longer relevant. And the next time you go to order, you might run into the same problem, or if you have to add a supplier, it can be very problematic. So, what's up, Mike?
It's a little bit of a tactical question, and maybe we can save it for later, but I was just wanted to get some thoughts on tools or ways to do document versioning. That was a thing that we ran into face first. So we can save that for later, but I wanted to bring that up.
Yes, that is a really good question. I honestly, I think that there is a lot of value that can be had out of managing that with just spreadsheets in the right format, in the right discipline and internal processes for far longer than most companies think. Because there's a lot of tools out there, but they can get very expensive. And if you don't actually have your internal processes understood and designed enough, it doesn't matter how nice the tool is, it's going to fall into disuse or create more problems than it solves. But yeah, we'll have to dig in on that more later individually. I just checked and we're basically halfway on these slides. So I'm going to try to pick up the pace a little bit here. I feel like I've also covered a lot of the stuff that is on these slides earlier. So stop me if you want to dig in on anything that I'm blowing by here. So now onto the supplier selection and contracting process. The general selection process is pretty easy to understand. You define what you want to purchase, then you decide who could maybe do that. You ask for quotes, you get the quotes back, and you compare them. I highly recommend, and this came up in earlier presentations, getting multiple quotes, because at the end of the day, things are changing now on a more quickly than ever before. And so going based off of your own assumptions of what things will cost and what things will cost at scale is a good place to start, but it's not a good place to build your business and make your strategic decisions off of. You cannot replace actually being able to pay somebody to do the thing if you're not really going to do it yourself. Highly recommend touring facilities and meeting the staff, getting samples, asking for references, finding out who they've worked with before, and vetting those suppliers. Understand that everybody that you're getting a quote from, if they give you a quote, they're trying to get your business, and they're going to do what they can to get your business. It's up to you to make sure that you have all the information. then the last step is you have to choose between them. And I find that it's helpful to develop your own sort of custom decision-making matrix, which we'll show you an example of later. There's a million documents that go into this process, and it's all pretty well documented and described in the book on this section around chapters 3 or around page 325. But some just general alphabet soup of all of this stuff. RFI is a request for information. This is basically go to their website nowadays. But earlier, if you're a bigger business, you can say, hey, look, I'm Apple. Send me your sales package. What can you do for me? But as a small company, it's less, you're going to come across this less often. NDAs, non-disclosure agreements, they're important to have in place, but also recognize that they're only as good as your ability to enforce them. And that's going to be very different internationally versus domestically. RFQs is a request for quote package, and this is all of the documents that we've talked about up to this point. This is your detailed specifications, every aspect of the design that this manufacturer would need in order to give you a price on whether they can quote it or not. If you don't have that fully outlined or your product is more generic, you can go with more of an RFP, which is a request for proposal, and that's where you define a higher level set of customer requirements and say, can you make something that does this? That often comes also in the sort of white labeling territory where it's like, you see this LED little thing that when you hit it, it lights up. And you say, hey, I like that and I want to sell it on my website. Can you make it blue and green? And that's more of an RFP. Quotes and A-to-A, actual to actual analysis. This is that process of sort of putting quotes together, but then normalizing them for all of the sort of different variables. What's the impact on cash flow? How much is cost up front? What's the minimum order quantity? Can they do one? What's their tack time? Like how many can they produce a week, and can it keep up with your demand, and for how long? There's a lot of variables more than just cost that go into it in selecting a supplier. Master Service Agreement, or MSA, there's a good checklist in the book of all the things, well, I won't say all, but a lot of things to consider in this, which are often neglected in early stage businesses when you're approaching a company. This sort of outlines all of the terms and conditions on how are you going to pay them and for what do they expect. Thanks for the heads up, Dylan. POs, you're probably all familiar with the purchase order. I'd say it used to be more of a legally binding contract, and now it's a little bit more fluid, but it's still something that oftentimes is critical to unlocking the start of a purchase. You send them a document, the PO, which defines this is what I want, and this is what I'm expecting to pay for it. It typically comes and is based off of a quote that you receive from the manufacturer. They would then follow up with an invoice, which says, okay, we provided this, now pay us this for it, and they'll reference your purchase order. A material authorization form, this is an MA. It's an important thing if you have very expensive or esoteric components or things that have a long lead time. You can actually outline this in your MSA to say, yes, you have the authority to purchase this and hold it for this period of time. We'll pay you this for it while you hold it. You can outline all of that stuff. That's best practices. Oftentimes people will neglect that and it'll just be fast and loose, and then you have to pick up the phone and say, do you have these components? Have you ordered them yet? Or are you ordering them now? Oh, and they have a 20-week lead time? Great. Your return material authorization form, or RMA, you may be familiar with this. It's oftentimes used on the consumer side with computers and electronics, which is the form that you have to submit in order to be eligible for returning something and getting a refund. This also goes with manufacturers. If you get a product and you inspect it on your inbound quality control and find that it was broken from the manufacturer, or if you get it back from one of your customers and it was a manufacturing defect, your MSA should outline a return materials authorization process for, can you send that product back to the manufacturer and will they reimburse you for the price that you paid to get it? Or do they not want to receive the product back and they'll just pay you and take your word for it? Is there some other element of documentation they require? Is any of this worth it at all? Just something to consider. Let's see. Okay, there's also a pretty good RFQ checklist in the book, and there's a ton of things that can be included in that. But the top things are sort of what we've already covered to date. Your description of your product. I can't understate how much understanding what your product does, what it looks like, what's the status of its development, what are the customer requirements. That's sort of your PRD is huge. Your PRD might be more complex and have a lot more pieces in it than you need to send for your initial RFQ, but it should be the place that captures at least what the things are that you should have ready to go, just so that somebody can understand exactly what your product does in 30 seconds and whether or not they can make it. Your bill of materials will then include all of the other parts on it, and they could say, I would definitely remember the assigned versus generic parts. So the critical thing for them to understand quickly whether or not they can quote it is, where are they going to get these components? Do they have them on the shelf because it's a commodity, or are they going to be expecting them from you? And so you are part of their lead time calculation on when they can provide it. Or is it something that they have to fabricate in-house or find an esoteric supplier for? Those are questions that should be immediately apparent on the BOM, because the quoting process is not insignificant. It's costing the manufacturer money to give you a quote because it takes them time to understand what your product is. Anything you can do to minimize the amount of time that they have to spend understanding what it is you're asking them is going to benefit you in the long run. So PRD, we talked about that as well. I wouldn't say that the bill of process is necessary for getting an initial quote, but it is something that's very helpful, even if it's literally just an assembly video of how do you take apart this product and how is it put together. That can give them a scope of magnitude if you're requesting a fully assembled box build of your product. Oftentimes things that are neglected from these, which we talked about earlier anyway, assembly drawings and part drawings. So understanding how the pieces of it go together, color, material, fit, and finish, and a listing of SKUs. Oftentimes similar components can be assembled in different ways to make different stock keeping units or products that are sold. This is like my ice trays, where it's the same two components, but swapping in one or two others makes it 4 SKUs. And then when I had 3 trays, that makes 7 SKUs, and it just compounds exponentially from there. Packaging concepts are another one that's oftentimes neglected. Many more things blasting through that you might want to define ahead of time in this project is the scope of the non-recurring engineering costs. Are they doing a significant amount of development work up front, or are you asking them to produce something that's already fully designed? Is there going to be a sampling procedure to this? Are you going to ask them to make 1 so you can verify it before they make 10, before they make 100? And then what are the go, no go signals or quality checks that will be in place before you order 1,000? Can they bank on you ordering 1,000, and so the sample is just a step in the process, or is it a fully purchase order for 1 and then a purchase order for 999? And all of your quality testing requirements are also important things to consider. Again, if you're cold calling a manufacturer, I wouldn't include a lot of this stuff, but you should have these things ready for that initial conversation. Non-compete clause, distribution requirements, a lot of manufacturers in the US will fulfill for you as a value-added service. So understanding how many shipments are you expecting them to make to how many different locations, that can shortcut their, can we do this or can we not? And how much are we going to charge you to do that? And then access to third parties. If you're, if you have a custom injection molded case that they need in order to assemble the fully finished product with the circuit board that they produce, are they going through you, or are they going directly to your supplier who makes the case, outlining that? So if you don't have these things defined or ready when you approach the manufacturer, oftentimes what will come back is not what you hoped for. They might just say, it will cost you $5 per product. And you say, well, wait a second, there's 100 components in there. How much does each component cost, and how much is the labor time, and what's the packaging? Is it going to be shipped in this packaging or that packaging? Do I have to pay a deposit? Is there NRE expenses built into this? All of these are things that you should be ready to ask them, either when they get the quote or while you're discussing how you want to see that cost broken down. Volume pricing, your RMA process, their distribution capabilities, and always remember to ask about intellectual property protection. A slide which Catalyst, our local MEP, provided to us for things to consider. Ask your manufacturer how they manage their intellectual property, and don't be afraid to ask for an NDA or send it to them before sending things. I will say you don't want to lead with that, because if you haven't gotten them excited about wanting to make the product in the first place, they get approached by inventors all the time who have nothing but a napkin sketch and say, can you make this for me? You don't want to come off as somebody like that. I have the next $1 million idea. Sign this NDA and let me tell you about it. They're going to never respond to you. So make sure you sell them on it first. Understand what is actually the most important to you. This goes back to the supplier relationship. How critical is this supplier to your overall business performance? Is this a strategic partnership? Is this a semi-transactional, or is this a key supplier, or is this a fully transactional? And then if you don't have an existing process for revision controls in place, this is something that I think is really valuable. And it goes in line with if you're not sure, don't be afraid to ask, because you'll oftentimes look better in their eyes by showing that you are humble and willing to understand their process and how it fits in. So if you don't have a version control process, you can ask them if they have one that you can dovetail into. If you don't have a quality management system, ask them what theirs is, and if you can use it to help manage your own. If they make a change to your BOM, ask them to send the printout of the BOM that they're using, and then catalog that in your file folders of saying, like, this is the latest version because it's the latest one that we got from that batch. There is a whole formal process, and the book talks about this too. ECOs, engineering change orders. There's a whole process for doing that, developed by larger companies that have actual engineering departments versus production departments versus manufacturing. And so you can create that checklist of saying and documenting, why did we request this change? How was the change made? What did it result in? A new version of the product, version 2 or whatever. Some specifics on the two big categories here. We'll talk about mechanical drawing packages and then electrical drawing packages. So for the tech packages that you would send. Mechanical drawing package, you'd ideally want to have both your part geometry and your technical drawing. So the two are not the same, but some things to consider and make sure that they are on your engineering drawing is these are generally 2D drawings. They have dimensions and tolerances. Datums are something that people oftentimes forget about. This is a reference plane where everything is measured from, and this is usually specific to the manufacturing method that is being used. It's essential to know how it's being made in order to find this, because if it's being held in a 5-axis vise versus a 3-axis machine, the datums might be different based on where they can actually measure things off of. Assembly drawings, how do these pieces fit together, and what are the critical tolerances of the interaction between these two pieces? part numbers, drawing numbers, revision dates, authors, who actually made those changes. How does this reference and link into your bill of materials or your assembly bill of process? Notes about post-processing, surface finish and roughness, material specifications. These are all things that are really good to document on the drawing itself. And that is why a CAD model is not the same as a technical drawing or a mechanical drawing. Mechanical drawing looks like it has much less information because it's a smaller file and can be printed out on a piece of paper. But oftentimes that piece of paper is what's going to follow your part around on the manufacturing floor to the people who are actually making it. The people who are actually making it, generally, it's changing nowadays, but it's still not anywhere near where everybody has a computer at their workstation and can look up your CAD file and go into the metadata of the CAD file to find out what material was spec'd in that piece of the component in the assembly. Very, very critical difference. This slide basically illustrates that. Those mechanical drawings will get passed around to a purchasing team, the tooling team, the manufacturing engineering team, the factory operators, and then at the end of the day, the quality engineering team who's going to inspect it to make sure that it meets the specs that you sent with it. That same drawing should convey all of the information needed by all of these different parties. This is an example of what a CAD file sort of represents in a physical format. It's a point cloud of three-dimensional objects, or maybe some parametric like equations which tell how lines are related to one another on it, or curves. A technical drawing looks more like this, where you have these sort of reference numbers, datums, tolerances on dimensions, locational differences, notes here. And then if we blow this up down onto that little corner on the side where it's what are the materials, how does this relate to the bill of materials, what grade is it, how much does this weigh? These are revision numbers and change orders. This is sort of the engineering change process, where who initiated the request, who made the change, what did it result in the difference? Are there notes that require additional explanation on that? Where did this come out of? What project is it related to? There's a reason that all of this stuff is located on those drawings. Now, on the electronic side of things, there are generally, I'd say, 4 different kinds of levels of drawings there. There's the PCB itself, which is just the board. And that has basically flat wires on it and holes for where the components go, or pads for where the components sit on. And so that is a physical object, which you can imagine is sort of made in like a machine shop. That's your router files. Of those holes are usually drilled into the boards. The boards are made elsewhere according to these Gerber or ODB++ files. The PCBA definition is then your component bill of materials. So what are all of the components that go onto that PCB board? And what are the specs on them? Are they specific? Are they generic? Are they assigned? Or what are the specs that they need to be? Are they polar or not? Are there test pads that need to be on the PCB in order to test different components? The other 2 documents, I would say, are the assembly side of that. How does it go together and what are those specs? And then all of the flex and wiring harnesses. So that's just the PCB and then the components that are placed on it by your SMT or your surface mount line. But then what happens to that board afterwards? Are there wires that connect that to other boards or need to be routed through a housing? There has to be drawings to document and spec all of that. Gerber files are what most people, I don't like this schematic diagram. That's like, this means something different. And a circuit diagram is also something very different. This is used analytically to evaluate the electrical performance of your circuits in theory. It does not generally mean much to most manufacturers. And most manufacturers will not call it a schematic or a circuit diagram they call that tech package your Gerber files, because the Gerber files include all of that information. What's the board? Where do the traces go? How do the components get placed on it? What are the components? That's generally the thing that they need, but it does not include those other additional files that I was mentioning, like the wiring harnesses and how does this connect to other boards? How does it fit into an enclosure? That's where it enters the sort of mechanical package side of things. Then we talk about color, material, and finish. This is something that people neglect until the very last minute, so it's useful to think about. What is your color? Specify it in Pantone numbers. What is the material? That can be very specific or be left very generic. It varies depending on, metal, plastic, wood, how you would specify that. Finish, there are a whole different glossary of industry standard terms to spec finishes and surface treatments, depending on what you'd want to do. We can talk about that more in office hours, or you can do a lot of research. Protolabs has some really good educational resources about how to spec these things. But it is going to vary depending on your manufacturing method and or your material and or the industry you're working in. Something that is useful as a generic term that I didn't do, which would have been very helpful in communicating with suppliers, is designating different surfaces. So if you think about a generic CAD file like this one, you just have this isometric view of your part. You can designate in colors, so literally like Microsoft Paint, fill this surface in and this surface in with a color and call that surface A. And then these are surfaces B, and then these are surfaces C, D, etc. And that can be a really useful tool in communicating to your supplier which of these surfaces is our customer going to see and be actually critical that it's aesthetically pleasing. Which of these could the customer see if they really tried, they might not necessarily care about. Which of these is not seen and is not functionally critical, which is not seen and functionally critical, etc. You can define that on your own, but it can be a useful document to have, which can also be a pain in the ass to sort of generate at the last minute whenever you get a question that you can't effectively answer. More things to consider: packaging. There's there's an entire industry dedicated to testing your packaging. There's an entire set of test standards to meet. Amazon is now developing their own, which are separate from any other industry standard process. There's many nuances to this. Is it going to be shipped on a pallet? Do you have master cartons that ship a fixed number of your box, your product? Do you have an inner carton box, which is then another gift box is inside that? Is the gift box the same as your point of purchase or point of sale box? So if it's sitting on a shelf in Target, is it sitting in a different box than you use to ship online orders? When you ship online orders, is it going to have that retail box, as I call it, or is it going to ship in a separate, just like e-commerce box? And what is your unboxing experience like? These are all things that are valuable to consider. They're all things that are really important to understanding your final costs, because they have to nest inside one another, and the external dimensions and total weight is what ultimately dictates your shipping and logistic options and costs. They will also all have their own set of different, they call them die lines. That is the technical drawing of packaging, is a die line. And that has its own set of specifications for how that box is going to be cut, finished, folded, glued, etc. Yeah, mentioned that already. Other manufacturing terminology: cycle time. How long does it take to start and end either a component or the overall product? Tack time is what is the production rate that you need to hit in order to meet your sales objective, and that can be linear throughout the year, or it can be exponential. Like 40% of my sales happen in the last 2 months of the year. So if I say that I sell 100 products a week for 48 weeks out of the year, but then in those last few weeks, I'm selling 500 a week, and the manufacturer is only capable of producing 100 a week, that's not going to be sufficient. So tack time, super important. Lead time, overall yield is something to also consider. This is going to be an alphabet soup for the next several slides, where I'm just going to try to really blast through this to stay on time. Yield, don't forget about the fact that if you order 100, there's going to be a certain defect rate. So you're probably going to get 95. If you really need 100, you should consider ordering more. Work in progress is how long does it take where your printed circuit boards are done, but you don't have a product because it's not in the housing and fully assembled or tested yet? Is there a bottleneck in your production time where there's one specific step that is limiting the whole process, and you could produce your product at a much higher rate if that bottleneck was eliminated? Downtime is the enemy of manufacturing businesses. They try to avoid any downtime on any piece of equipment, because that means that capital investment that they made on that is no longer generating money for them. Things to consider. This is useful for when you're touring a facility or if you're trying to set up your own manufacturing operations. Think about these things because it can help you to begin streamlining your operations or assessing whether or not a supplier is actually a good fit for you. Do they have a receiving area for receiving material coming in? Do they have an inbound quality control area so that they can assess whether or not that's acceptable before moving it into an inventory control area? Materials, parts, and subassembly inventory, do they have the ability to separate that so that they can stop and start your production process and fit it in with other jobs that they're working on? Or if you're doing it yourself, they have a kitting area where they can assemble X number of screws into batches so that it can streamline the production process. What does their fabrication line look like? How many parallel lines do they have set up? What does their assembly and production lines look like? Do they have the ability to flex and add more or less assembly lines? Do they have an in-process inventory area? So if they have to stop and start something, it can be kept organized and not lost track of. Is there a packaging area so that they can provide you with a finished good before shipping it out? Or is that something that they're saying they can do and then have to set up something on an ad hoc basis? Is there a finished goods inventory area so that they can warehouse that for you and ship to your customers? So when you're ordering 100 a month, and 1 month you sell 20, and then the next month you sell 120, do they have enough area, like physical area, to inventory enough of your products to buffer that? And then shipping area, oftentimes combined with their receiving area. Other areas, rework area. So some manufacturers will pride themselves on their ability to provide aftermarket services. Do they have an area dedicated to that where they can receive broken products, assess what's wrong with them, fix them and send them back out, or reject them and replace them? A quarantine area for things that have failed QA and cannot be sold and are waiting to be decided what happens with it. Do they have a QA lab for quality assurance and testing parts? There's a list of things to consider when you tour the facility in the book on page 331 through 333. Here's a bunch of them. We sort of talked about all of this earlier. Here's an example of that supplier comparison matrix that I had mentioned earlier. So you'd list the critical things that you're looking for in vetting a supplier. And oftentimes most people will think about cost, number one, but it can also be many other things. Your quotes from 3 different contract manufacturers, and then how important is that particular differentiator? So when you multiply the weight across those things and total it all up, it can hopefully give you an idea of who to choose. This is very important, in my opinion. There's 3 things that drive manufacturing: cost, quality, and lead time. And the old saying goes that you can have 2, but not 3. So generally speaking, this is critical for negotiations, because if you really, really push somebody to get all 3, probably not going to be good at any of them. And whenever you're pushing somebody on cost, either quality or lead time is going to suffer. If you really start to try to push down into one corner of this, the other two suffer. But see you later, Mike. But if you get to, it's important to decide what is most important to you. And be very wary of, if they say something costs a certain amount, ask yourself, are they really trying to screw you, or is that just actually how much it costs? Because if you start trying to get them to go lower, they will probably figure out ways to cut corners on quality or lead time in order to meet that objective. Some common mistakes from the build for scale slides about selecting your suppliers: always going for the lowest bidder, forgetting about quality, selecting a supplier that specializes in a different volume. So if you are working with the biggest supplier out there, but they want to do big, large batches and you aren't ready to do that, it's not going to be the best fit. Assuming that production quality is the supplier's responsibility, that is a very dangerous thing. Ultimately, this goes with project management. No matter how efficient their systems are at managing this stuff, it is still ultimately falling on you to manage your project and to manage your quality. And that could just be checking up on their system, but you still have to know to ask those questions. Also, sole sourcing critical components or parts without a backup plan is a huge common mistake. Remember that you're selecting a strategic partner, not just a manufacturer. Supplier management. Anybody who has to jump, feel free. If you have any questions along the way, just throw them out there, but I'll just keep going. Supplier management. Options for managing your supplier. You can do everything yourself, but there are also middlemen, brokers, trading companies who specialize in manufacturing, so they can manage different types of manufacturers for you. There are full service US-based OEMs and CMs who can do that type of stuff. There's also consulting firms. This all goes back to the earlier slide about defining and understanding who you're talking to and what they're actually providing for you. Supplier negotiations. Definitely have a strategy in hand before you even ask for a quote. Remember to calculate the effect on alternative procurement on the supplier ahead of time. So this might mean if you ask for a quote for 1,000, are they going to give you 1,000, or do you have room to negotiate and say, okay, I want a quote for 1,000, but I will pay for them 100 at a time over the next 6 months. Does that help you or hurt you? Can they produce them in batches throughout the year, which makes it easier and more flexible in their production time? Or does their economy of scale actually come from ordering 1,000 and making 1,000 at one time? Important distinction to make while negotiating with that supplier. Developing a clear ownership of quality issues is also critical for that negotiation process. You're not going to save money on anything that's ill-defined. If they quote you on a price assuming that you're managing quality entirely, and then you start asking them to manage quality, you've already issued the purchase order and they can't necessarily charge you more, so they're going to drag their feet on delivering that, and that can create a lot of tension. So it's very helpful to make sure that you really fully understand who is responsible for what during the negotiation process, because that can give you the opportunity to ask questions about reducing price or improving quality. Also, asking the questions and getting the invoice or the quote broken down, because that allows you to make sure that your estimate of how much this should cost is aligned with their estimate. If you have a product that has 100 components in it, and they give you a price that this will cost you $200 per component, but you don't necessarily know if one component in that results in 80% of your BOM, or the biggest component results 10% of your BOM. You don't have enough information to understand whether or not their quote is reasonable. A shortcut to that is getting many quotes from many manufacturers and seeing if there's any outliers in that distribution, but it still doesn't provide you with all the information if you don't have an accurate understanding of how much each component should cost. More best practices. Remember to ensure you understand who owns the tooling, and understand if the manufacturing process is unique or a competitive advantage for you, or if it's actually just a commodity service. Understand who develops the documentation to define all of this stuff. What is like your service agreement, your purchase orders? Are you defining that, or are they? Don't forget to explore areas of mutual gain. Can a subcontractor provide any additional services for them that you already use? Say somebody like a machine shop doesn't have a good anodizer, but you have a good relationship with an anodizer. If you can provide them with the introduction to that anodizer and it ultimately works out well for them, that provides value to that machine shop, which now reflects positively on you. Also, capital equipment. If they don't have an ultrasonic welder in-house and your product needs one, can you essentially justify the capital equipment expenditure for them to buy one, which then makes their services more valuable to more customers, and you don't have to pay for the ultrasonic welder? That is an important thing to consider in negotiations. Intellectual property protection. At the end of the day, I think the whole intellectual property discussion is a really interesting one. And the number one piece of advice I would give you is understand where your actual competitive advantage comes from. Where does your real value of your product and your business come from? Is it in the design? Is it in the manufacturing process? Is it in the data that you collect? Is it your brand? Is it a customer or distributor relationship? That can inform you, because if the value is ultimately in the design itself or the manufacturing process, that is when it is most critical for you to really get your NDAs in place, understand the business model of your supplier, and whether they're actually incentivized to try to steal your design or steal your idea, whether it's developing a whole new manufacturing process that nobody else has ever done before, and that's something that they could start selling to other customers, which would undermine your market share. Are these things that are actually important, or is it just hypothetical? Another aspect of it is, are you managing the supply chain in-house, and is there any one component of your product that is the actual competitive advantage, your performance? For instance, if it's something like software, if you have an array of electronic components that are assembled together into a device that has no moving parts, anybody can make that. You're buying those components from suppliers that anybody can buy from, and then that's it. But anybody can assemble them in that way. But without the software, it doesn't do anything. So as long as you protect the software, it doesn't really matter to get an NDA in place on the components and the assembly of the components. But best practice is to get an NDA and make sure that your critical IP is actually protected. I am running out of time myself here because I'm already late for my next meeting, but I'm going to blast through the rest of these slides. Don't forget to consider the trade-off of how much is it going to cost to actually defend a patent that you do have, and do you have that capital and ability to defend it? If you don't patent it, will somebody else patent it? This is a great differentiator between, can you rely on a trade secret, or do you actually need to get a patent? Because if you get a patent, then it is disclosed to the world, and somebody might develop a workaround. But if nobody knows how you do it in the first place, it might be better to not tell anybody. Managing your supply base. As companies grow, you'll want to add more suppliers. So being able to rate and rank your suppliers and how reliable they are is very valuable. There are a lot of external credibility indicators like these ISO 13485, 1400, 4500, 9001 that manufacturers will advertise on their websites and be able to tell you that they can rank themselves, whether or not they have that, if it's important for your product and industry. Consider the benefits and trade-offs for single sourcing versus dual sourcing or more. See you, Stephanie. Thanks for sticking around. Single sourcing, inventory management, SKU traceability, quality, everything is easier if you only have a sole supplier or if you're doing it in-house. But with dual sourcing, you have the expanded resiliency of your supply chain. You can risk mitigate for part shortages. You have the ability to respond to surges in demand and compete. So that's all I've got. I wanted to mention this earlier. I put a link to this form here for manufacturing tours. Take a chance to submit that survey and let us know if there's any particular manufacturers that you would like to tour. We will try to set up tours with local suppliers in the spring. And so it would be good to know what you're most interested in and what you hope to get out of it. Homework again, identify your list of potential suppliers, and then also continue to work on your prototyping test quality, prototyping quality test plan. Reminder, fill out the surveys let us know how this presentation was. Obviously it went very long, too much information in it, but if there's any other things that you would like to see defined here, please do. And then let us know if you watched this recording after it was published live from the column L in the overall curriculum overview. But unfortunately, we don't really have time for questions, maybe one or two quick ones if anybody's still hanging in there. All right. Have a good day, guys.
Catch you later.